Okay, listen, dear students. In the last class, we are completed up to 8 questions from level 3 chemical kinetics chapter objective. Let's see that next question, ninth question. See, this question is very easy. We have to find the rate expression. The given equation, let's see, 2a plus 3b is equals to products. Okay, now excess of a is present. A is excess. Excess means what, ma'am? It's the rate is independent. Rate is independent on concentration of A. Hence, order with respect to A is 0. So the rate expression or rate is only depends on concentration of A only. Concentration of B only. B, its order, let it may be X. So we have to find out X value. Have to find out a X value from the given data. See, the concentration of A changes. Concentration of B is equals to 0.1 and concentration of B is equals to 0.4. At that case, rate R2 is equals to 2R1. The rate is becomes a double. Then we have to find out a X value. Now let's see, the R1 is equals to K into concentration of B 0.1 whole power X. R2 is equals to 2R1 is equals to K into concentration of B is 0.4 whole to the power of X. See, this equation is 1, this equation is 2, then 2 by 1 implies 2R1 by R1. Then R1 will cancel, is equals to K and K will cancel. 0.4 by 0.1 whole to the power of X is nothing but 2 is equals to 4 power X is nothing but 2 power 1 is equals to 2 power 2x. Let's see, the x is equals to, otherwise 2x is equal to 1, then x is equals to 1 by 2. X is equal to 1 by 2. Now, what is the rate expression? The rate is equals to dx by dt, change in the concentration with respect to time is equals to k into concentration of B whole to the power of 1 by 2. See, the answer is fourth option is correct. Fourth option is correct. Okay, clear? So in the given question, what we have to find out? Rate expression we have to find out. See, two reactants are present, A and B, but the concentration of A is excess means the order with respect to A is 0, because excess of concentration of reactants are present, then the rate is independent of that concentration. That's why order with respect to B is equal to A is equal to 0. Then the rate order of the reaction is depends on the concentration of B only. Okay, so according to that, B concentration is changes from 0.1 to 0.4, then the rate becomes double. So just we have to find out the rate at R1 means the concentration of B is equals to 0.1, then rate is equals to R1, concentration of B is equals to 0.4, then the rate is R2 is equals to 2R1. According to that equations 1 and 2, we are solved X value, then X is equal to 1 by 2 means order of this reaction is equals to 1 by 2. Order of the reaction is equal to 1 by 2 because the order with respect to A is equal to 0. Okay, let's see that next question. 10th question. Okay, in the 10th question, what they gave, listen dear students, a reaction is catalyzed by H plus ions, then the presence of HA means one reactant, one acid, the rate constant HA is converted into H plus plus A minus its rate constant. Its rate constant. Its rate constant K1 is equals to how much they gave? 2 into 10 to the power of minus 3. Okay, 2 into 10 to the power of minus 3 minute inverse. And another reactant HB. HB is converted into H plus B minus. Then its rate constant K2 is equals to 1 into 10 to the power of minus 3 minute inverse. Okay, what we have to find out, Ha and Hb both are strong acid, then the relative strength of acids, relative strength is directly proportional to rate constant. So the relative strength of Ha by the relative strength of Hb is equals to K1 by K2 is equals to 2 into 10 to the power of minus 3 by 1 into 10 to the power of minus 3 is equals to 2. So the answer is 2. Answer is 2. Okay. Let's see. Go for next question. 11th question, dear students. Listen. It's very easy. See, benzene diazonium chloride. Benzene diazonium chloride. So in Sandmeyer reaction, the preparation of chlorobenzene or bromobenzene, what we are using? Diazotizonium salts we are using. Benzene diazonium chloride we are using. Then this benzene diazonium chloride on heating in the presence of cuprous chloride. Okay, then the product is chlorobenzene is formed plus N2 gas is formed. See. Okay, now here the question is related to N2 gas and it is a first order reaction. Then we have to find out its rate constant. Okay, if reaction is completed, if reaction is 100% completed, then volume of N2 is equals to 50 liters. Volume of N2 how much is present, ma? 50 liters is present. But if time t is equals to 10 minutes, then volume of N2 formed in reaction is equals to 10 liters. Therefore, after 10 minutes, the final volume or before 10 minutes, sorry ma, before 10 minutes, the final volume of N2 is equals to, means after before completion of the reaction, means before 10 minutes completion of the reaction, the final volume of N2 is equals to 50 minus 10 is equals to 40 liters. Okay, 40 liters are present. Then we have to find out the rate constant. See, it is first order reaction. The rate constant K is equals to 2.303 by T into log final final volume of N2 by volume of N2 at T is equals to 10 minutes. Sorry. Volume of N2 before completion of reaction, before 10 minutes completion of reaction. Completion of a reaction. Okay. See that K is equals to 2.303 by 10 into log 50 by 40. Okay, just no need to solve this question completely. According to the options only we have to solve. Is nothing but K is equals to 2.303 by 10 into log 50 by 40 is nothing but 5 by 4 is nothing but 1.25. 1.25 units are minute inverse. See, the answer is second option. Okay, dear student, this kind of question we have to find out the rate with respect to one of the product. Here in the chemical reaction, one of the product is nitrogen gas. When the reaction is completed 100%, then volume of N2 how much is present? 50 liters is present. Okay, now we have to find out this rate of this reaction. Rate of this reaction at 10 minutes time. See, means the reaction is complete. For completion of the reaction takes maybe 1 hour time. In 1 hour time, maybe it forms 50 liters. But before 10 minutes means at 50 minutes time, how much volume of N2 is formed, that is 40 liters is formed. At that means still 10 minutes is there for completion of the reaction. At 10 minutes time, actually the 10 minutes time how much volume of N2 maybe forms? 40 liters, sorry, 10 liters is present. But it takes remaining 50 minutes time, then it completely convert into 50 liters. But in 10 minutes time, how much volume of N2 is present? Only 10 liters. See, according to that final means N2 is converted into N2. Let it, you have to consider like this only, that initial volume is 50 liters at T is equals to 10 minutes, then formed 10 liters. Now at 10 minutes time how much volume of N2 is left? 50 minus 10 is equal to 40. This is like, that's why here I did 50 by 40. Then his value is 1.25. The answer is second option. Second option is correct. Okay, let's go for next question. 12th question, let's see. When the initial concentration is changed from 0.5 to 1.0 liters, the time, okay, the time of half-life reactions of certain reaction is found to be 50 seconds and 25 seconds, and calculate the order of the reaction. See, it's very easy. We know that what is the relation half-life and initial concentration? T half is inversely proportional to 1 by a to the power of n minus 1. 1 by a to the power of n minus 1, where a is initial concentration. T half 1 by t half 2 is equals to a2 by a1 whole to the power of n minus 1. Here the first half-life period, the concentration is changed from 0.5 and 1.0. This is a1, this is a2. Okay, half-life periods t1 is 50 and t2 is 25. Then 50 by 25 is equals to a2 is 1 by 0.5, 1 by 0.5 whole to the power of n minus 1 is nothing but 2 is equal to 1 by 0.5 is nothing but 2 power n minus 1. Here 2 power 1 is there, then n minus 1 is equal to 1. From this n is equal to 2. See what is the order of this reaction? Order is equal to 2. Order of this reaction is 2. See the answer is 2. Second option. See, whenever that initial concentrations are changed, means different initial concentrations. At the time, half-life periods they gave. Means initial concentration is 50 mole per liter, 0.5 mole per liter. Then its T off is equal to A1. Initial concentration A1 is equal to 0.5 mole per liter. Mole per liter, and its half-life period is equal to 50 seconds, and A2 is equals to 1.0 mole per liter. Its half-life period is equal to 25 seconds. See what is the find? We have to find the n value. N means order of this reaction. See what is the relation between that initial concentration and half-life period. T of is inversely proportional to 1 by a to the power of n minus 1. 1 by a to the power of n minus 1. According to that formula, we are calculating order of the reaction. Okay, let's see 13th question. 13th question very easy ma. SO2 Cl2 is converted to SO2 gas plus Cl2. The pressure of SO2 Cl2 at T time 0 and 20 minutes respectively is 700 and 350 mm. So when log P0 by P plots respective time T, then the slope is equal to their ask. See for this question it is SO2 Cl2 sulfuryl chloride on decompose converted into SO2 plus Cl2 is first order reaction. First order reaction. Okay, for this case rate constant K is equals to at initially at time T is equals to 0 means initial pressure is equal to 700. P0 is equals to 700 mm. And if time T is equals to 20 minutes, then P 20 minutes is equal to 350 mm. 350 mm is present, then K is equals to 2.303 by T. 20 into log P naught P naught by P. P naught by P is nothing but P20 is equals to P is equals to 350 mm of Hg. Actually, no need to use these values now. This is one formula. So for this formula, general formula is equals to K is equals to 2.303 by T into log P naught by P. See, we have to make a graph between log P naught by P is equals to K into T by 2.303. Okay, now this equation is like this: y is equals to mx Then we have to make one graph between log P naught by P with respect to time. The graph is going through the origin. Its slope m is equals to k by 2.303. So we have to find out k value. Then this k is equals to 2.303 by 20 into log P naught is 700 by 350 is nothing but how many times it will cancel? 2 times it will cancel. Then k is equals to 2.303 by 20 into log 12 is 0.3. Log 12 is 0.3. Then we are getting k is approximately 1.5 into, on simplification we are getting 1.5 into 10 to the power of minus 2 minute inverse. Okay, then slope is equal to, we have to find out, actually in this equation we have to find out slope. Slope is equals to m is equals to k value by 2.303. K is actually 2.303 by 20 into 0.3 by 2.303. This 2.303 will cancel. Then 0.3 by 20 will be present. Then it is equal to okay. 0.3 by 20 is equal to 1.5 into 10 to the power of minus 2. Means first option is correct. 1.5 into 10 to the power of minus 2. See, units are time is, how much time they gave? The time is 20 minutes. Now the answer is 1.5 into 10 to the power of minus 2 minute inverse. See, the answer is 1.505 into 10 to the power of minus 2 minute inverse, means third option is correct. See, here units also very important. Okay. See here, indirectly slope for this equation, for this relation, the slope is equal to k by 2.303. So k value we are finding out. K is equal to 2.303 by t into log p naught by p. So time is equal to 20 minutes, p naught is equal to 700 and p is equal to 350. This is on simplification. We are getting the directly k is equal to, just don't solve completely, 2.303 by 20 into 0.3 by 20, because sorry, by 2.303. Then this 2.303 cancel. Then slope is equal to 0.3 by 20. On simplification is nothing but 1.5 into 10 to the power of minus 2 minute inverse. So the answer is third option. Okay, let's go for next question. Let's see 14th question. The rate is nothing but k into concentration of H plus ions whole to the power of n. See here, the pH is changes from 2 to 1, then the rate becomes 100 times. See, R1 is equals to k into concentration of H plus ions whole to the power of n. Okay, now at this R1, pH is equals to 2. pH is nothing but minus log H plus ions concentration. Minus log H plus ions concentration. is equals to 2, then H plus ions concentration is nothing but 10 to the power of minus 2 will comes. At that case R1 is equals to K into 10 to the power of minus 2 whole power n. Okay, this is equation 1. If pH is changed from 2 to 1, if pH is equals to 1, then the concentration of H plus ions is equals to 10 to the power of minus 1. Then the rate R2 is equals to is 100 times more than R1. 100 into R1 is equals to K into 10 to the power of minus 1 whole to the power of n. This is equation 2. From this equation 1 and equation 2, we have to find out n value. See, then 2 divided by 1 gives 100 is equal to 100 is equals to 10 to the power of minus 1 whole to the power of n by 10 to the power of minus 2 whole to the power of n. This is nothing but 10 to the power of this 100 is nothing but 10 square is nothing but 10 to the power 100 by 10. 100 by 10 is nothing but 10 to the power of n. Then n is equals to 2. N is equals to 2. The answer is second option. Okay. Let's go for next question. 15th question. Let's see the 15th question. The reactions 1, 2, 3 are present. Their orders. The reactions orders is first order, second order and third order reactions are present like this. So what they gave for this case, when the concentrations are expressed in mole per liters, what will be the relation between K1 and K2 and K3? K1, K2 and K3. They are asked. See, in this case, the relation, if concentrations are expressed in mole per liters, then K1 dash, K2 dash and K3 dash relation we need to find out. If for this case, rate is equals to K into A power X, where X is equal to 1 means for first order reaction. Concentration of A is equals to, see here, the K1 is equal to K2 is equal to K3. That is the relation when the concentrations are present in mole per liter. Then we have to find out the relation K1 dash, K2 dash and K3 dash when the concentrations are expressed in mole per ml. Mole per ml. Okay. See, in this case, concentration of A is equals to A mole per liter is nothing but concentration of A is equals to A into 10 to the power of 3 mole per ml. Now R1 means the first order reaction, N is equals to 1. Then R1 is equals to K1 into concentration of A into 10 to the power of 3 whole to the power of 1, because X is equal to 1 means order is equal to 1. For this case, this R1 is equals to K1 into 10 to the power of 3 into concentration of A whole to the power of 1. This K1 into 10 to the power of 3 is nothing but K1 dash into concentration of A power 1. In the same way, R2 is equals to K2 into A into 10 to the power of 3 whole square. is nothing but this R2 is equals to K2 into 10 to the power of 6 into a whole square. This value we have to, this is one constant that we have to consider as K2 dash into a concentration of a whole square. Next R3 is equals to K3 into a into 10 to the power of 3 whole square, whole cube, because the order is equal to 3. X is equal to 2 and here x is equal to 3. Then R3 is equals to K3 into 10 to the power of 9 into concentration of a whole cube. Concentration of a whole cube, let it be R3 is equals to K3 dash into concentration of a whole cube. But the given reaction K1 dash is equals to K1 into, here K1 is equals to K1 dash into 10 to the power of 3. Then sorry, K1 dash okay, let's see, compare that both. This K1 into 10 to the power of minus 3 is nothing but K1 dash. K1 dash is equals to K1 into 10 to the power of 3. See, from this K1 is equals to K1 dash by 10 to the power of 3. In the same way, K2 is equals to K2 dash by 10 to the power of 6. The same way K3 is equals to K3 dash by 10 to the power of 9. But K1 is equals to K2 is equals to K3 is gives rise to K1 is gives rise to K1 dash by 10 to the power of 3 is equals to K2 dash by 10 to the power of 6 is equals to K3 dash by 10 to the power of 9. Then the important relation between K1 dash and K2 dash and K3 dash is equal to K1 dash is equals to K2 dash into 10 to the power of minus 3 is equals to K3 dash into 10 to the power of minus 6. Why means because this equation completely we have to divide it with 10 to the power of 3 multiplied with 10 to the power of 3. This is comes to this side means what it happens here, 10 to the power of 3 will cancel, then 10 to the power of denominator is present 10 to the power of 3, then it goes to upside means 10 to the power of minus 3. Similarly, K1 is equals to K3 dash into 10 to the power of 3 by 10 to the power of 9 is equal to K3 dash into 10 to the power of minus 6. Like option is equal to K1, actually here dash we need to give. That is K1 dash is equal to K2 dash into 10 to the power of minus 3 is equal to K3 dash into 10 to the power of minus 6. See, the correct relation is second option. See, dear students, this question is nothing but the concentration of A is before in mole per liter. Then the rate constants are K1, K2, K3. Their orders are 1, 2, 3. If the concentration of A becomes mole per ml, then what is the relation between the new rate constants? That is that we have to consider as K1 dash and K2 dash and K3 dash. In that case, K1 dash is equal to K2 dash into 10 to the power of minus 3 is equal to K3 dash into 10 to the power of minus 6. That is important relation. Okay, let's go for next question. 16th question, let's see what they gave in 16th question. 900 ml of that 16th question, 900 ml of pure dry O2 is subjected into silent electrical discharge. After 10 minutes, the volume ozonised oxygen is formed by 870 ml. Means this O2 is converted into O3. Okay. 3 moles of O2 is converted into 2 moles of O3. Okay, initially how much O2 is present? Initially they gave 900 ml. That let it be X, sorry, let it be A, then O3 ozonized oxygen formation is 0, then is converted into at a time T. If time is equals to T, then this A is converted, some decomposed into 3X. Then how much ozone is formed? That is 2X is formed. Then at the time the total volume A minus 3X plus 2X is equals to 870 ml. Then A minus X is equals to 870. Then X is equals to 900 minus 870 is equals to 30 ml. Now the final, this is final. Therefore, final volume of O2 is equals to A minus 3X. Then X is equal to 30, 900 minus 3 into 30 is nothing but 900 minus 90. 900 minus 90 is equals to 810 ml. 810 ml of oxygen is left. Then now the average rate in ml per minute, the rate is equals to the average rate change in the volume. Change in the volume means volume by time. Change in the volume is 900 minus 810 by time is equal to 10 minutes. Is nothing but 90 by 10. 90 by 10 is nothing but 9 ml per minute. That is the average rate of this reaction. Let's see, 900 ml of pure oxygen is present. Then after 10 minutes is ozonized, means it converted into ozone. Then the total volume, how much it is appeared? 870 ml it is appeared. This sum of this is equals to 870 ml is appeared. But how much oxygen is converted? Oxygen is decomposed, that is 2x is decomposed. 2x is decomposed. Okay. Then x is equal to 30 means 60 ml of ozone is formed. 60 ml of 2O3 is formed. Okay, but how much it is decomposed means out of 900 ml of O2, 3x is decomposed. The 3x is nothing but 90 ml. Then the finally how much oxygen is present out of 900? 810 ml is present. Now change in the rate. Our average rate is nothing but change in the volume. 900 minus 810 by 10 is equals to 9 ml per minute. 9 ml per minute is the average rate. Okay, let's see 17th question. Seventeenth question is very easy. Just listen, dear students. 17th question. At some temperature, the rate constant for the decomposition of HI on gold surface is 0.08 mole per liter second inverse. Now 2HI, what is the order of the reaction? How long time it will take when the concentration of HI dropped from 1.5 to 0.3? 1.5 to 0.3 they asked. Let's see. The rate constant K is equals to 0.08 mole per liter second inverse based on the units of K. Units of K, it is zero order reaction. Okay, it's very clear. So order is came. It is zero order reaction. Now we have to find out how much time is required for the conversion of the concentration of HI changes from 1.5 to 0.3. That we have to find out. For this case, rate is equals to, rate is nothing but change in the concentration by time interval is equals to K into concentration of HI whole to the power of 0 is nothing but change of concentration by time is equals to K. Change of concentration is how much? Is nothing but 1.5 minus 0.3. 0.3 by time interval. So the time we have to find out is equals to 0.08. Then 1.5 by 1.5 minus 0.3 is nothing but 1.2 by T is equals to 0.08. Then T is equals to 0.08 by 1.2. Sorry, T is equals to 1.2 by 0.08. This is on simplification, we'll get 15 seconds. See, during that 15 seconds time, the concentration of HI changes from 1.5 to 0.3 and it belongs to zero order reaction. So the answer is second option. So the answer is the second option. Here order of the reaction we are finding out based on the rate constant units. Okay, then the time we have to find out. Rate is equals to constant. Rate is nothing but change in the concentration with respect to time is equal to K. Then time we are find out, that is 15 seconds. Okay. Okay students, the remaining questions we will discuss in the next class.